3D images such as cone beam computed tomography can improve the treatment planning and follow-up with superimposition methods. Sometimes, 2D measurements on 3D models or X-rays show no difference comparing two sides of one structure. A lack of difference could be accurate, or could be due to incorrect placing of landmarks or anatomical variations. When the same model is examined with 3D measurements, 3D images can properly identify asymmetry using superimposition methods, such as a color map. This analysis in 3D image can provide better understanding of bilateral structures. 3D color maps and overlays can localize and quantify asymmetry with better accuracy due to the difficulty of placing landmarks in 2D and anatomical variations. Creating a color map file allows for us to see the degree of changes by adding colors and changing ranges. This tutorial explains how to do that. Load the time point surface modules, which are in a .vtk format, into 3D Slicer. You can always change the display to a 3D only view. Go to the Modules drop-down menu, select Shape Analysis, and then click on the Model to Model Distance module. For the VTK File 1 option, make sure you select the second time point. And for the VTK File 2 option, make sure you select the first time point. This inversion is necessary because the color map will be created in the file selected in the VTK File 1 option. For the VTK output file, select the option Create and Rename New Model. Rename the file as a color map file. Click OK. Then check Signed Distance. Click Apply and wait for it to complete. Once it's completed, go ahead and save the color map by clicking the Save icon. In the window that pops up, it's not necessary to save the scene file, so go ahead and uncheck it. You have the option to rename the file and change the file format, but keep the VTK file format for now. You can also change the directory here. Click Save. After saving, go to the Modules drop-down menu, select Surface Models, then click the Shape Population Viewer module. For the parameter under Shape Population Viewer, click Create New Command Line Module, and then click Apply. A new window will pop up. If the new window already has loaded files, go to File at the top of the page and click Delete All. If nothing is open in the window, go ahead and drag and drop the color map into this window. Color-coded maps allow 3D analysis. In this color map, each color represents a different amount of change. Here, it's possible to change the background color and the text color. At the top of the page, go to Options, then click Window Colors. Here, we change the window color to black. Color-coded maps allow 3D analysis. In this color map, each color represents a different amount of change. You can change the range to determine the difference you want each color to represent. Here, we use negative and positive 3.5 millimeters. The range can be adjusted until you see small areas in red. If you set the green arrow at 0, it'll show little or no change between T1 and T2 models. The red side of the spectrum displays surfaces with outward change, also known as a positive value of mean surface distance between T1 and T2 models. We set yellow as a midpoint at 1.75 millimeters. You can add arrows which correspond to new colors, allowing you to see more differences with other color changes. For example, here we add dark blue on the opposite side of red, set at negative 3.5 millimeters. These blue colors will display inward change, or a negative value of the mean surface distance. We added a light blue set at negative 1.75 as a midpoint. Adding new colors makes it possible to analyze the changes in the bone or teeth related to the growth or treatment in specific regions. Comparing and associating the findings with the overlay can provide greater understanding. Here, the T1 model is red, and the superimposed T2 model is a semi-transparent white to allow qualitative assessment of change. We can notice that the incisors were flaring in consequence of the treatment, and they are yellow in color, which corresponds to 1.75 millimeters in the color bar. When the color map is zoomed in and compared to the overlay, we observe that the condyle had a posterior displacement due to resorption in its anterior area, marked as dark blue and corresponds to negative 3.5 millimeters. The posterior part of the ramus showed bone growth and is displayed as yellow that corresponds to 1.75 millimeters. In the condyle area, growth was in the posterior superior direction and was more evident than in the posterior area of the ramus, reaching 3.5 millimeters in some specific red regions. Dive into the color map world and enjoy its applications.